Hi, this is Dr. Syed from DBS Institute of Technology, Kavali. Today we are going to discuss about gear tooth measurements. This is unit number 3, metrology and measurements. Contents. You can see the contents of this presentation. Introduction. Nomenclature of gear teeth, gear measurement, and another two, that is concentricity of gear teeth, alignment of each tooth, then rolling gear test, measurement of individual elements of a gear tooth, vernier caliper. So this is an introduction to gear measurements. Gear is a mechanical device used for transmission of power and motion. Gear can also be used to achieve variable speeds by using different drives. They transmit power by meshing with each other gear. Manufactured precisely and accurately. The gear tooths are manufactured very precisely and accurately. There are mainly two types of profiles are used for manufacturing the gear teeth. They are involute profile and cycloidal profile. So by the introduction of the involute profile, from the involute we can make a gear tooth, and from a cycloidal we can make a gear tooth. You can see here involute profile. So you know well in the first year itself we might have drawn what's an involute and how to draw it, that also you know it. So you can see the involute gear design was designed by Leonard Euler. It is defined as the locus of a point on a straight line which rolls around the cylinder without slipping. So this red line, what you are saying, is the locus of the point. From here to here, it is gear tooth. It is a gear tooth height. From where gear tooth will slip to another gear tooth. Cycloidal profile. First we have seen involutive profile, and now we are seeing cycloidal profile. Cycloid is designed as a curve traced by a point on the circumference of the circle, which rolls without slipping on a flexible straight line. You can see here the pitch line and the gears. There is a gear A is there, and at the bottom there is a gear P is there. So from here we can draw the cycloid profile. Now we will go to the terminology of a gear teeth. So one is pitch circle is there. It's one of the important one, pitch circle. It is an imaginary circle by which pure rolling action will give the same motion as the actual gear. You can see here, the top there is an addendum circle. Under this addendum circle, there will be a pitch circle. This is the imaginary line. And again, if you go to the bottom, this is the dedendum circle. So, pitch circle, imaginary circle, by which pure rolling action would give the same motion as the actual gear. Number two, pitch circle diameter. It is the diameter of the circle by which pure rolling action would produce the same motion as the toothed gear. Number three, resume angle. Sorry. Number three is pressure angle. It is the angle between the common normal to two gear teeth at the point contact and the common tangent at the pitch point. This is the pressure angle. Number four is addendum. It is the radial distance from the pitch angle to the tip of the tooth. Then dedendum circle. Dedendum. It is the radial distance from the pitch circle to the radial from pitch circle to the bottom of the tooth. Dedendum minus addendum is good. This is a clearance. Number six is clearance. It is defined as the now you can see number seven, face of tooth. The face of the tooth, it is the part of the tooth surface which is above the pitch surface. Then flank of the tooth. It is the part of the tooth surface which is tying between the pitch surface. Circular pitch. It is the distance measured on the circumferences of the pitch circle from a point on one tooth to the corresponding point on the adjacent tooth. Then diametral pitch. It is the diameter. It is the ratio of the number of the. It is the ratio of the number of the teeth, the pitch circle to the diameter of the pitch circle. Then PD is equal T by D. Module, it is the ratio of pitch circle diameter in the diameter in the millimeters to the number of teeth, that is M is equal D by T. Then total depth. It is the radial distance between the addendum and a dedendum circle. Then tooth thickness. It is the width of the tooth measured along the pitch circle from the from the intercept with the flank to its intercept with the other flank of the same tooth. Then face width. It is the width of the gear tooth measured as parallel to its axis. working depth. Working depth. It is the radial distance from addendum circle to the clearance circle, and it is the difference between the it is the clearance between the tooth space and the mating tooth thickness. So these are all the different parts of the gate tooth. Then concentricity of teeth. Mounting the gear between the bench centers. Placing standard roller in each toothpaste and measuring the deviation using a dial indicator. Using a projector, in which case the teeth are brought the against the stop, and each edge of the tooth of the screen should coincide with the line of the screen. Using gear testing between using a gear alignment of each tooth. Alignment of each tooth. Analytical method. It's a slow method and tedious. It is used to determine the following teeth elements: profile, spacing, pitch, runout, or accessibility of concentricity. That's the thing is, so it is used to determine the following, that is profile of the tooth, spacing of the tooth, pitching to, analytical method. It's a slow method and tedious. It's used to determine the following teeth elements, that is profile, spacing, pitch, runout, eccentricity or concentricity, thickness of tooth, backlash. The functional method, running the test together with complete rolling gear test. It's used in mass production of the gearways. It is less time and accurate errors. Rolling gear test. It's used in mass production of the gear wheel. Less time and accurate results. Variation of center distance when the gear to be tested is rotated under spring pressure. Again, a master gear. Machine use is called as Parkinson gear tester. It reveals an error in both form, pitches, and concentration of the pitch. Parkinson gear tester. Gear wheel under test. You can see here. The right side master gear wheel is here. Master gear is a fixed garage. This is mobile garage under gear. Mechanical dial indicator. Mobile carriage. Gear wheel test. Fixed garage. Parkinson gear tester. Parking gear tester. You fix the gear wheel under this test and you will rotate it with the master gear wheel. Mechanical dial indicator will be there. And there will be one calibrated spring is attached both with the fixed garage to the moving garage. Mobile garage. Two carriages, one fixed and other movable, are mounted on the base. The movable carriage is spring-loaded towards the fixed carriage. Two spindles are mounted in a parallel plane on each carriage and are made to suit the bore of the gear wheels. A dial gauge is made to test against the movable carriage. The two gears in mesh are then rotated by hand and variations in the dial gauge and the variations in the dial gauge readings are observed. So how we'll do it? Two carriages, one fixed and other movable gear are mounted on the base. The mobile carriage is spring-loaded and spring-loaded toward the fixed gauge. Two spindles are mounted in a parallel plane on each carriage and are made to suit the bore of the gear wheels. A dial gauge is made to rest against the mobile gauges. The two gears in mesh are then rotated by hand and variation in the dial gauge readings are observed. Measurement of individual elements of gear. Tooth thickness is generally measured along the pitch circle and is therefore the pitch line thickness of the tooth. Following are various methods of measuring the gear tooth thickness. Measurement of tooth thickness by gear tooth vernier caliper. Number B is constant crowd method. Number C is base tangent method. Number D is measurement by dimension or pins. Now you can see here gear tooth vernier caliper. This gear tooth vernier caliper is also available in our college lab. You can see this gear tooth vernier caliper studied properly and try. We are going to do some exercise and you are going to measure the gear tooth sizes with this gear tooth vernier caliper. You can see here this gear tooth vernier caliper is just like in a L shape, that is 90 degrees. And you can see here the gear tooth is inserted between the two jaws. But the measurement will be taken by over the pitch circle, that is from the top of the gear tooth, a there will be some obstruction by which the tooth doesn't enter inside. So by see we can see here in the vertical way what is the height of this gear tooth we can measure, and the horizontal way, that is a horizontal scale is there. In the horizontal scale we can see the width of the gear tooth. At the vertical gear tooth, at the vertical vernier, we can see the we can measure the height of the gear tooth. So there are some calculations are there. These calculations, it is, if you know the different parts and if you know the sizes of these parts, and if you apply these formulas, we can calculate each and every part of a gear tooth. Now, do you have any questions, please? This is the end of the chapter. But of course, this practical is available in the lab. We'll have to go to the lab and do the practicals and find out the sizes of the parts of a gear tooth. It's a very interesting one. We do it. However, if you have any questions, if you have any doubts, you can ask me. I can explain you. Any questions, please? No questions. Okay. Thank you very much. Again, tomorrow we'll meet you. Goodbye.